admit I want to do a bit of a plug for CDK, Amazon's cloud development kit. I'm a huge fan. I couldn't do it any other way. So if you want to know about CDK, I'll be happy to take you through it. But yeah, back to Git. Git origins, basics, and some things you might not know. So I think one of the comments that I remember my brother making was that as developers, we don't practice. You know, if you're a pianist, you have to practice. You have to practice so you can perform. And very often what we do is we perform most of the time. You don't get a chance to practice. So I'm hoping that this talk might kind of be a practice for us. So I've taken a sort of a look at Git that you wouldn't ordinarily get to take as a normal sort of run-of-the-mill stuff, your normal day-to-day job as a coder. It kind of gives you, hopefully gives you some insight into how it works so that you can really make it work for you. Anyway, without much further ado, let's continue. So just a little bit about me. Computer science honors in computer science back in UKZN in 2000. Got my first job in Cape Town, March 2001. And I started out with CVS. So you'll find a lot of CVS and SVN references in this talk on Git. And I can tell you about a lot about the transition between the two. People that are used to SVN take a lot of time to get used to Git. Maybe what you can do if you can help me is how do I get where's the participants here? Let me see where I get more participants. Anyway, if anybody that's used SVN, maybe how do I get the participant list here? Maybe just put your mic on and say, yes, I've used SVN.
I've used it.
I've used it.
Are you still using it, or is it in the past tense?
No, thankfully in the past tense.
Yeah, so the transition is sometimes challenging for people that want to be able to commit separate files. Yeah, so that's one of the big things of Git. It doesn't really do separate files. So I've as you can see, I've used CVS, SVN, and more recently Git, although Git is in the last 8 years. So I've been using Git for quite a while now. I can remember well making the transition. And then I currently work for a company called Zumkani. We do fire protection, intruder protection, and insurance for them. And I work mainly in Python. So a little bit of background on that score. I've been almost 20 years in Java, and I've been in 8 months in Python. So yeah. So anyway, just a little bit about, now we're going to go into the origins of Git. I don't know if anybody know that Linus Torvalds is the guy that wrote it. And I'm going to play you a little excerpt from a video that he did back in the day, a talk on Git. I joke that if you haven't watched the video, then you know, I almost feel like you should rather be listening to his talk rather than listening to me. But do yourself a favor and go and find that video after the talk or sometime and listen to him talk about Git. He's always entertaining. So he wrote it as a replacement for BitKeeper. That was what he was using to do the kernel development at the time. And so some of the decisions that he took, you can see his use case is very much in focus in the video. He talks about how he had 22,000 kernels, so he was versioning one file at a time. He was interested in versioning multiple, and merging was a really big deal for him. And so if you ask why is Git made this way, then those are some of the reasons. I want to play for you a little excerpt from his video. Let me just figure out how to do this now. Let me go back to non-full screen.
I've never actually used CVS for the kernel. For the first 10 years of kernel maintenance, we literally used tarballs and patches, which is a much superior source control management system than CVS is. But I did end up using CVS for 7 years at a commercial company, and I hate it with a passion. When I say I hate CVS with a passion, I have to also say that if there are any SVN users in Subversion, users in the audience, you might want to leave. Because my hatred of CVS has meant that I see Subversion as being the most pointless project ever started. Because the slogan for Subversion for a while was CVS done right, or something like that. And if you start with that kind of slogan, there's nowhere you can go. It's like, there is no way to do CVS right.
Okay, so as you can hear, he's got some pretty strong opinions about how you can do things. Very worth listening to that whole talk. I'll definitely put it on the chat for you guys to take in. Let me just put my present back here. Right. So can you see my screen again? Some basics, eh?
Yep.
Okay, cool. Now where do I get the participants? I'd like to see the, oh, they were there. No, that's not going to work. Anyway, I'm not so afraid how to use Zoom, I must say. Ah, there. Okay, got them. Good stuff. Okay, cool. So I was going to say that if you have anything to say, you want to ask a question, maybe I found that the chat is often quite a nice way to put it there. You want to make a comment. I often find that sometimes there's this whole conversation going in the background. The nice thing about Zoom is that you can have these side conversations and the speaker isn't even aware. So I might be able to follow that potentially. And if you have any questions, what I'd prefer to do is keep them for a bit later in the talk. Hopefully some of them will be answered. And especially if there's some clarification questions, because I might go a little bit fast or I might sort of gloss over things. Some of the things I don't quite understand myself that I'm looking at. So bear with me. Anyway, so some basics. Let's go, yeah. Okay, so distributed. So Git is distributed. That means each person has a copy of the source code and can commit locally. It was a bit of a game changer for those of us who've used SVN, CVS, and Perforce and whatever else. It's distributed means that everybody's got a copy of the source repository. And what's interesting is that, you know, the pattern is often that there's one sort of master repository, but the reality is that in Git, there is not a concept of a master repository. There's just a whole bunch of siblings. Although at the same time, there is something subtly different about what you want to make the master repository a bare repository. Now, for those of us who've ever made hosted ourselves, you might be aware of what that means. It basically means that this repository doesn't have a piece of source code. It doesn't actually have source code it's only for storing, not for actually working against. So it tracks history as a whole. So that means it doesn't track history of individual files. As I sort of go into depth, you'll see what that actually means. We're going to delve into some of the sort of the under the cover stuff of Git, and hopefully we can find some interesting things. And then, so that's why I say if you want to get the history of an individual file, you kind of have to run a query. You have to calculate, you know, it has to actually sort of traverse the tree and find the history. It also means why it's very hard to delete a file and its history from Git. And then it uses hashes to track commits. It makes extensive use of hashes. I was blown away by how important and how significant and how useful this hashing approach is. Okay, so what we're going to do now is where were we? We're going to go, yes, where were we? Let's practice. Okay, so we're going to start practicing. Right, so let's see. I'm going to actually bring myself let me get myself a shell here. Just want to detach this terminal so you can see it better, make it bigger. Okay, so we're going to go and I've actually created it. I was practicing earlier, so I'm going to make this again. So we're going to deep delve into the nether regions of Git now. It's deep south devs demo. Okay, so we're going to make another one. I'm going to go git init deep south devs demo. Okay, so that's how you create yourself a new Git repo. And we're going to cd into that one. And we're going to make ourselves a new file. So we're going to go, first we're going to create a file. So this is our first file. And we're going to, yeah, that's going to echo first file to first.txt, okay? So now we have a file in our repo, and we're going to git.add first file, because we always have to add it if it's new. And then we're going to commit that. First file, okay. Now, what has it done? Let's go and have a look. So we're going to use some of the nice commands that Git has got. that lets you sort of see what's actually going on. So we're going to go get, you cat file -p, so that gives you a pretty print of the head. So the head is the pointer to the last, it's like the most recent commits, basically the tip of your tree. Now there you can see there's a tree. That's an interesting one, isn't it? We've got tree, author, committer, and first file. So the first file is the comment, of course. Now we're going to go and see what you can do is you can do a get cat file on all those and all these numbers. So we're going to go get cat file -p, and the nice thing about these hashes is you can only use, you know, you can only use the first 4 letters and it still works. So now we have something going on there. That tree is a blob, and its name is first or text. And we can even go and look at exactly what is going on there. So we're going to go, let's go and have a look at that blob. There's our file. Look at that. There's the thing that we've added. Now, where are those things stored? Let's go and have a look. So here we have in our .git folder, we're going to go to objects, and we're going to see them. So there we have, you can see, what are we looking for? Blob 303, blob 30, and this is stored by the first 2 digits. 2 digits are the directory name, and then the rest of the hash is in there. So you can see we're going to see there, and there's our 303f. That's the hash of that fella. So that's what Git has done to actually store the file in the repo. So now what it's going to do, if you want to check out, is it'll go to the head. Now remember we talked about head? Let's go and find the head. Where's that? There's the head there. Now what is that? So that's refs/head/master. We can go into, it was in refs, and we can see what's going on there. We can actually go to heads, and now we have the master, and that is, as you can see, that is the tip of your repo. But we haven't seen that number yet. We've only seen that. We've only seen a few other ones. We've seen, what have we seen here? Let's just scroll up in the history here. We've seen the tree one. We've seen the blob one. But we haven't seen this particular one. Now, this one is the commit hash. So what it has done is it's taken the file and it's hashed it, and it's stored it in its objects. And then it's created another sort of a blob, well, amalgamation of, it's created a commit hash. And what is that commit hash? The commit hash is a hash of this content with an extra little bit, and the extra bit is what it is. So it's a commit and the size. Now I'm just going to bring up my cheat sheet here. That's something that let me just find my cheat sheet. Where did I put it now? Here, where's my cheat sheet? It's gone. Come on, Michael. That you can still see that. Here it is here. Okay, I've got my cheat sheet. So now we can do some stuff. Right. So you can see here. So now we're going to go, what it does, it takes this bit. Can you see my console, hey? Just put a thumbs up, you can see the console.
Yeah, we can see the console.
Okay, cool. So it's going to put in the front. Now, what are we looking for? We're looking for, this is the commit hash, 9D19. That's the commit hash. And it's going to prepend, we're going to prepend this commit 191, which is the commit. It's a commit and the length to this whole hash that we've got here, plus a null header, and it's going to give us the hash. So watch now. We're going to do this. This is the magic part. Okay, so we're going to see that you can see that now we've got the commit 191 in front, and the tree actually, and then we're going to go pop that to SHA1 sum, and we're going to get 9D191. 9D191. So I'm just going to pause here and say, are you guys following? Are you actually seeing what's happening here?
No, I mean it looks great from my perspective, but as in, I think I can maybe follow if you just set it once more, a little bit slower.
Yeah, no problem, no problem. So what get is done when I went. Actually, let's just start from the beginning again. So let's just go like that. We're gonna start again. So we're gonna go get init deep stuff devs demo. Okay, so now we're starting with a blank slate. There's nothing in this repo now, right? It's just check here. There's nothing here. It's just the stuff, right? Now we're going to create a file.
Can you put something else in that file, like as in not to say, like maybe call it just file content and then call the file first? Okay, like you just did there. That's fine.
Yeah, that's fine. So that's your. What we're gonna do now is we're gonna make two files. We're gonna make two commits. So we're gonna see what it's gonna do there, because it starts getting a bit more interesting. All right. So now we're gonna go get add first.text get commits -m first commit. Right. We need to put the file name, don't we? First.text. So what has it done now? Let's go to .get and have a look.
Sorry, Michael, to disturb you every time, but is it just me? How do we get this bottom little thing over the It's over the.
Is it too? Is it too low here? Should I make it?
Yeah. If you could just do that.
Yeah, that's.
It's actually the same. Yeah, I don't know.
Maybe that's going to be.
If you could just move the window side up, yeah, that would be great.
Yeah. Okay. Cool. So now we're going to see. Let's go to objects. .get/objects. So now we have a bunch of hashes in our objects. We got a hash. We're going to see that -p. So now we're going to get so this is the details of the head. So that's the head points to the tip of our repo, basically. It's our, like, if we add stuff to the repo, we're going to be adding it to the head. So that is the details of that commit. And that commit was that tree one you see there. That's the whole state of the repo at that point. That we're talking all the files in it. It blew my mind when I was looking at this to say that that's actually the whole repo. And we can see that by going file -p 24/7f. All right. Now you watch and you notice that let me actually take you through another repo that is sort of a bit bigger. One of the random ones that I work on. Let's see what we're going to do. Let's go to S3 indexer, and we're going to go get cat file -p head. And so we're going to go get that one. That's the head. Now we're going to cat file -p a62f, and you can see there's more there now. There's also not that much, but the point is that that's the whole thing. And you can see that if it's a folder, it's got a tree. So we can actually delve deeper into that one. Let's go and have a look at what that one's got in it. 5D7. And then each of those blobs, there's more trees. So that's a whole folder structure. And if you want to actually see the file itself, we're going to go get cat file -p b3f6, and we can actually see the contents of the file. Now, when you actually go into in here, and you can't actually go here because in here everything is compressed. So if we took that same one, you can see how big these repos get pretty quickly. If we took that one b3f6 and we catted it out, we'd get gibberish because it's compressed, and it's using I think it's using zlib compression. So we could actually manually decompress it if we wanted to, but Git's there to help us out. Okay, so we're going to go drop back to our demo repo. And now where were we on this one? So we were looking at, we have now got, I see, I just need to go back now because we've deleted it, so it's been lost. Where is it now? Get /temp/deep devs demo. Okay, so now we have our repo, right? So we're going to go get cat file -p head. Okay, so now we've got, let me pull that up. Okay, so there's our first commit, but the actual commit hash is 2185, etc., etc. So how do they calculate that? Because they've just got the details of the commit. So what they do is they add a header to that thing, which is what it is plus the size of that whole payload, plus a null header plus the actual payload itself. So that's what they use to calculate the hash, and the hash that we're looking for is 2185. So we're going to go pipe that to SHA-1 sum, and there we have 2185. Okay. So now if you need to check out something, you select the hash you want, and Git can sort of build up the whole repo from that hash by traversing the tree, because the state of the tree at that point is literally, let's just go find out what that one is. The state of the tree at this point is literally this hash here. We're gonna see what's in that hash, and that hash has got, I just need a 247F. Okay, so that's the state of the tree. Now let's add another file. Second file to, this is our second.txt. So now we're going to git add second.txt. And then we're going to go git commit -m second file. Let's actually go that. -m second file. Okay. Now, what do you think is going to happen now when we pop out the details of that commit? What we're going to see is that there's an extra parent being added, because now there's two commits. So the first commit obviously didn't have a parent, that's the root, but we're going to see a second one which is going to actually have a parent in it. As you can see, there it is. So this one is now the parent commit. The state of the commit before me is that one, and the tree is obviously there's a whole bunch of new blobs, hashes being added, and it's the tree. So let's have a look at that tree one. -p cd90. As you can see now, we've got the state of the repo is that there's two blobs. One blob is first.txt and its hash is CE1, and the second blob is 1C59 and its name is second.txt. So we can actually get the details of that 159, and you can see what it is, etc., etc. And as you add more files and you add more commits, this thing is going to grow bigger and bigger and bigger. Okay. So now what about a branch? What about, let's look at maybe the head. So
sorry, this might be a silly question, but that second file that gets piped out there, is that a commit message? Or is that the file context?
The commit message is here. I'll show you the commit message, cat file -p head. The commit message is there. Sorry, the file and the commit message are very similar, but the commit message is in the actual commit itself. And that, of course, is also a blob in the Git store. We can get that out by, we actually are viewing that Git store blob now, because head is a synonym for the latest commit. And let's going to see what that one is. That one will be, there's the head. The head's pointing to refs. So we're going to go refs, heads, and we're going to cat master. And here's the actual commit. That's the hash of our commits. We're going to go git cat file -p 9436, and we're going to get the details of our commit. That's not going to work. Okay, so there's the details of our commit. Right. Okay, so what we're going to do now is we're going to push this thing to some remote repo. So before we do that, I just need to create us a GitHub repo. Actually, I didn't see why I shouldn't show you that. Let's go here, new GitHub repo, deep south devs. Okay. And I'm not gonna add anything because I want it to be blank so we can just push our changes to it. So we're gonna create it, and there's our repo. Right, so we're going to go back to our terminal, and we're going to go git remote add. Is it origin first? I think it's origin first. Origin is like a label for a remote repo, and we're going to do that. Right. Now we're going to say git push origin. Oh. So what's happened now? So the thing to bear in mind is that, well, one of the things to grasp with Git is that there's got this concept of these local branches and a concept of a remote tracking branch. And a remote tracking branch is a branch that tracks the remote. Surprise, surprise. That's what it's for. It's sort of analogous. It tracks the remote branch. So in order to actually push something to a remote branch, we need to actually create this remote tracking branch. So let's do what it suggests. So we're going to set the upstream. We're going to go git push dash set upstream origin master. And now it's going to create us a remote tracking branch. But now we're going to really things are going to get interesting, because you're going to see how is it actually storing those branches. So now we have a new folder in our git store called remotes. And the remotes, what it's doing here is it's saying the remote master is pointing to 9436. But the reality is that both the remote tracking branch and the local branch are currently on the same point, pointing to the same thing. So they'll both have the same hash. And what I want to do is I want to switch over to Eclipse, and I want to show you these remote tracking branches. Let me just add our new. That's the way it's looking. I'm just going to load this repo into Eclipse for you quickly, and then there's my deep south demo. There it is. Okay, and I'm going to go deep south demo. There you go. Okay, references, remotes, and branches. Okay, so here we have. I hope you can see that. Here we have the master and the remote tracking branch. And whenever you've got a local branch, you've always got a referenced upstream branch. I guess what they call them upstream branches clearly in our world. All right, so I'm going to just cheat a little bit. I'm going to change that in the meantime because I need to demonstrate that as well. So now there's an upstream branch, but you can see that all a branch is just a pointer. It's just a hash, and then from there it can sort of generate the rest of it. So what we're going to do is we're going to go to our. Let me just see. Here we are. So have we practiced? Right. So let's just go back to our presentation for a second. You can see that the commit hash combines the source tree of the commit. So basically the state of the whole repo. This was something that was quite remarkable when I realized I was actually doing this. I thought it was only sort of just the changes, but it's actually the whole repo. The parent commit SHA1, the author info, the committer info, the commit message, and then the null terminated header containing the word commit and the length in bytes. I mean, you can read it for yourself there. And that link, I'll share the slides, or I'll post this link. That link tells you all about, this is where I'm getting it all from, basically, that link. Okay. So let me just go to, now I want to show you a little bit of branching. What's going to happen if I add a new file here and I pull? So we can go through what exactly is pull. Let's create a new file here. So we're going to create a new file called third. This is our third file. We're going to call it third.txt, and we're going to go commit the file. This is the commit for the third file. Okay, so we're going to commit directly and commit new branch. All right, so now we're going to go and we're going to do a fetch. Now, what is a fetch? What exactly is a fetch? A fetch updates the remote tracking branch, or let's call it the upstream branch of your branch that you're on. It doesn't actually pull the changes into your branch. It just updates the remote tracking branch. So we're going to go git fetch. Now, what do we expect? Well, what I'm expecting is that the current tip or head or sort of top or tip, I don't know what they call it in Git parlance. I'm expecting the content of this to change, because this is the one that we're going to pull. Don't forget, I've made a change on the remotes, so there should be something, a new stuff coming in. So let's go git fetch. And there it is. And now we're going to go to that place, ref slash remote slash origin, and we're going to cat master, and it used to be 943, and now it's 069. So now the remote tracking branch is pointing to a different place. And the point is now that we can see that there's an update on the remote tracking branch, but there's no update locally. So in order to bring that update in locally, we're going to do a git pull, and that is going to synchronize the remote tracking branch with the local branch. And now if we did now we're going to cat our local one. Now where was our local one? It was on refs heads slash master. So now that's 069, and so is the one in remotes. Okay. So now we have, now we have these are the same. And this actually did a merge. I don't know if you noticed that, you don't know if you realized that, but it actually did a merge, but it would have been a fast forward merge. Okay, so let's just go through what does it all mean. Well, one of the strengths of this is that I can always tell. It's very easy for Git to figure out if changes have been merged already. So if you've got a sequence of hashes and it compares them and it says, hey, wait a minute, both trees or both sequences have got this hash, therefore it knows, oh right, that's already been merged. But if there's a hash in the one sequence that's not in the other sequence, it knows, oh right, that hash needs to be pulled in. As happened now when the remote tracking branch was pointing to an extra hash that wasn't that the local branch wasn't pointing to or didn't have. It also means that if you change an old commit, guess what? All the subsequent commits need to change. All the subsequent hashes need to change, because the parent commit, the child hash is dependent on the parent hash. And that's why it's very hard to change a commit that you made a week ago, because that means that all the hashes, all the subsequent hashes are going to have to be recalculated. It means one of Linus's big design goals was to ensure that data was never lost. And the fact that he uses hashes extensively means that as soon as there's a mismatch between the content and the hash, he knows, oh right, something's gone wrong. And he knows that there's something wrong. And that's why it's so hard to rewrite your history. If you want to rewrite the history, you basically have to enforce, or you force everyone to have to repull and to overwrite their changes potentially. So that's what happens if you rewrite the history. Your fellow developers are going to have to update their histories, which is why in a lot of contexts you're not allowed to rewrite the history. It's just no access allowed. And then how do you get the history of an individual file? Let's just go and have a little skiz at that and work and see if that's possible. So what it's gonna have to do is it's gonna have to let's just go head -p head. It's actually a lot easier than I thought. Ah, look at that. So that's the one that came from GitHub rather. Some extra stuff, some extra fancy stuff to extra security. I'm not entirely sure exactly what it's doing and how it works, but it looks like it's got some sort of validation that's included. The commit comment is still there, but it's got some PGP signature to sort of ensure having extra layer of security. But I actually want to see the tree for this one. So git cat file -p that tree 687b, and you can see that there's three files now. Now what Git will do, what Git can do is as soon as it detects that there's a different hash in a different commit, then it knows the file has changed. So what it'll do is it'll traverse up the tree and it'll compare each hash with each hash of each file and see if they're different. If they're different, it knows, oh right, there's a difference. The other strength of this approach is that if two files are the same, it's going to store only one version of that file because it's going to store the hash only once. Okay, so where were we? Let's go back to the presentation. So that's why it's not sort of, it's possible, but it's not, you know, historing of individual files, not like a first-class citizen in Git. Okay, so you can imagine then how hard it would be to delete a file and its history. You know, you've got this, you inadvertently committed some very sensitive information like a password or an access key or a secret or something like that. It's challenging for Git to do that. The whole history, pretty much every commit that touched that file, I think, is going to have to change. Okay, so let's just take a breather. Let me just go and get some water, and I'll be back in 2 minutes. Right. Now, where were we? Okay, so what I want to do quickly is take you through let me just go here. What is this fast forward merge? So here we have what happened here earlier. I just did a pull, right? I pulled the changes from the remote to my local. And before I pulled, you could see you can see that there's a remote tracking pointing to 1 and a local pointing to 1. They're both pointing to the same commit. Then what happened was I did a fetch and I got 2 more commits, and the remote tracking is now pointing to the third commit. Now, when I did the pull and there was no extra, so there was no extra commits locally, all that happened was the local was updated. And that's a fast forward merge. All that has changed is the pointer. All that was required to change was that the pointer now points to the same place as the remote branch. So that's what it means by a fast forward merge. It means that there's no work to be done on the local branch. There's been no changes on the local branch since the in between. So the remote branch was created. There was work done on that other branch, but there was no work done on the local branch that you're merging into. And all you need to do then is just update the pointer. There'll be no merge commit because all you're doing is changing a pointer, and so it's unnecessary to do a merge commit. But that's the concept of fast forward merge. Now I'm just going to go back here. All right, so let's go and have a look at some branching. Actually, no, before I do that, I want to show you what happens when you've got some remote changes and some local changes coming in, and we're going to actually have a look at a little bit of merging at the same time. So we're going to create a new file here. We're going to call it fourth.txt, fourth.file.txt, and we're going to go, this is the fourth file, is the fourth file, come on. Okay, this is the fourth file, and we're going to say, this is our fourth commit. Okay, we're going to go commit that file, and then we're going to go locally, and we're going to do our fifth. So let's go local, and we're going to go git, and we're going to go echo. This is our fifth file, and we're going to go fifth.txt. Is that fifth? Yes, that's right. Git add fifth.txt and git commit -m our fifth commit. Okay. All right, so let's just have a look. We've got git log. We can see that's our whole history. We can go git cat file -p. Let's get head. You can see that there's a tree there. So let's just have a look at that tree quickly. You know, it would be quite interesting is if we F41E, as you can see, there's the fourth, there's all 4 of our files now are in that one. And if you look at, for example, a previous commit, let's have a look at what is in the previous commit. Let's have a look at what is in that commit. Git cat file dash. Actually, you can just go commit as well. It also works. 9463. 9463. No, not 9436, sorry. 6. That one's tree state is CD non-zero, so get cat file dash p non CD non-zero. You can see the state of that tree is only got 2 files in it. So that's how it's tracking the changes as it's going along. So now we've got to change locally and we've got to change remote. So we're going to do a get. Actually, let's just live on the edge and do a get pull, shall we? Now, what has it done now? We have to merge the branch in. So we're going to merge. Yeah, we just want to write this. We're going to make a merge commit. Now, cat file dash p head. Check at that. There's 2 parents. Can you see that? So that's because it was a merge. So there was two commits, 2 hashes, 2 commits that were merged into one at this point. And that's why you see the 2 parents. Let me show you it in a graphical context, because I think it'll be a bit more clearer if you can see that. Where is history here? I can't find history. I'm going to have to just quickly import this project so I can see history. Deep South Dev demo, go back there, and then just select a working set so that I don't pollute the thing too much. And that's the other one that I created. There's a new one that I missed, and edit active working sets, Deep South Devs demo. Let's take away that one. Okay, so now we're going to see graphically what's going on, which is a bit easier to understand. Okay, so there's those hashes all rendered graphically. You can see we've got the merge commit and the 5th and the 4th, and then the original. Now this one here, Git can know that there's 2 children, because the parents are going to be the parents of that commit and the parent of that commit is going to be the same. So maybe we can actually use our git cat file tool and actually have a look at that. So let's see, git cat file dash p ba02, and that one's parent is 069, and the other commit is cd non-e, and that one's parent commit is also 069. Okay, so that's what's happened. That's why we've got the situation we've got with this merge. Now, I always want to try. So the thing is, we don't really like having too many merge commits in our repo, because this is actually just normal operation, isn't it? So developer pulled, developer did some work, committed some stuff, and then pulled from the remote and brought in some changes. We don't really like to see so many merge commits in our repo. We'd rather have a clean repo with just one sort of track. And the way that we do that is when we use a rebase as our branching strategy. So Eclipse helps you quite a lot, because it actually can it configured. I don't know if you saw me change it. I'm going to change it. I'm going to change it back to Rebase, the strategy back to Rebase, and then you can see the difference. So what Rebase is it's something that takes a bunch of commits on one branch and replays them on another one. It's almost like it redoes them. It sort of replays them. It replays them, exactly what it does. But the one thing about Rebase you have to bear in mind is that it's going to have to change the hashes. So you can't really rebase if you've already pushed, because if you're going to rebase when you've already pushed, you're going to have to rewrite the hashes. But if your changes are only local, then it's okay to rebase. So what we're going to do is we're going to change the branching strategy here to Rebase. That's actually that's right, the pulling strategy, right? And now we're going to see what the difference is. So now we're going to go to our Git sub repo again. We're going to create another file. Maybe what file is this one? Now this is 6th, isn't it? 4th, well, yeah, it's 6th, that's right, because our 5th is local. So we're going to create 6th here. This is the 6th. file, and we're going to say creating 6.txt. Okay, we're going to go create new file, commit new file, and we're going to go locally and do the same thing. We're going to go echo. Now we're going to create number seven to 7.txt. Git add 7.txt. Git commit 7.txt-m. This is our 7th file commit. Okay. Right. Now we're going to do a git pull. And we're going to see what it's done. See, as you can see, first reminding head to replay work on top of it, applying our 5th commit. This is our 7th file commit. So now we're going to go to our clips again, and we're going to see what the history is, and they've got a nice clean history with no merges. I don't know how it got rid of the other merge, but the other merge is not there either. I'm not entirely sure what's going on there. I think it might be just because of the way that my Eclipse is only showing me certain of the branches. Okay, let's just do a pull here to make sure we're all up to date. I'm pretty sure we are. Yeah, everything's up to date. Let's go back to here and get the history. There you go, team show history. Okay, so there we have the history is now rebased. So what that does is it replays your changes onto the remote branch. That's taken me a while to get my head around. That's what it's actually doing. It's replaying my remote changes onto the remote branch. Okay, now where were we? Let's go back to our presentation and get some. So let's just some questions. Maybe we have sort of answers. We have covered them, but just to recap. So what does checkout branch do? Checkout branch creates the local branch and the remote tracking branch so that you can then track the branches, track the changes. What is a remote tracking branch? We've kind of covered that. What does fetch do? Fetch only updates the remote tracking branch, or the upstream branch, whichever nomenclature you want to use. And pull updates the remote branch and updates the local branch. So pulls the changes all the way down. And you prefer to pull with Rebase because it doesn't pollute your history with lots of merge commits. Okay, now let's just shoot the breeze a little bit. We're going to create a new branch. How do you create a new branch with command line? I don't even know. Let me just be lazy, and I'm going to use my tools to do it.
If you do git checkout -b, yeah, there we go in the chat.
I thought it was checkout. So then -b means create a new branch, right?
It's a shortcut for git branch, the name, and then git checkout that new branch you created.
So will that do it? Can you see that? Git checkout -b dev. Okay. So what's that going to do? What do we think that's going to do? What I think it's going to do is it's going to add a new entry into ref/heads maybe. Yeah. See, all it's done is it added a new entry in there, which is our new pointer. So now the current heads and the current head is now changed to. Sorry, let me go back to .git. The current head is changed to point to that new place. So whenever you commit, that's what's it's gonna add to that. It's gonna sort of hook its wagon that's gonna be the parent. So that's what it's gonna use as the parent. So that's all it's done. It's very, very lightweight, as you can see. So yes, let me just go here. All right, so working with branches, let's go into the next one. We've done this one already. This is the fast forward merge thing. And then so then a few sort of tips, tricks, and techniques. Maybe you've come across them, maybe you haven't. We've got the concept of an interactive rebase. Now, has anybody ever done an interactive rebase? Do you know what that is?
Not me.
Okay, so an interactive rebase allows you to rewrite your history quite nicely. So for example, you say to yourself, listen, there's a spelling mistake in this commit. there's like something wrong with that one. Fortunately, we control both the remote and the local here. So even though we're going to rewrite the history, that's okay. So we're going to, I'm going to live on the edge, and I'm going to use get to do it. Although I might be embarrassed by my, that's right. That should be it. Rebase interactive and 2185. Yeah. Okay. So now what it's got is this, what we're doing is we're rebasing, interactive rebasing from that commit, the first commit, the very first one. And as you can see, now this is what we can do now. We want to squash a commit. So squash means put the commit into the previous commit. So let's change this to squash. We want to squash that one because we want those to be combined. We want to skip. What is the skip? There must be a skip here. How do you, so skip is just delete the thing, just delete the whole line. And now that commit is going to be gone in rebase. And then we can also do a reword. Okay, so that means edit the commits, the commit actual comments. So let's go, let's hope this works. So now this is the squash. So as you can see, it's giving me both of the files. So we're gonna, no, I don't know how to use this tool. How do you delete? Is it no? It's not like that. Oh boy, it shows you how often I use the command line to do get stuff. So now that's going to be the new commit message, and those two have been squashed. And now we're going to reword. This is the one we're rewording. So this is the reword. Let's just into that. Okay, and now we're going to go and look at our history, and now there's a whole new branch that is our rebase. We haven't lost what we had before, but now it's been rewritten. You can on our dev branch has been rewritten. So now we can push that instead of pushing the ugly history that we had. Push branch dev. Let's push this branch. Let's change it to rebase because we like rebase rather. And then we're going to push that. So now I'm just being lazy and not using the command line. So there you go. Okay. So then, oh boy, wait. So then we've got interactive rebase. We've got cherry pick. Cherry pick allows you to take a commit on one branch and put it onto another branch. It's like a lightweight rebase. It's just for one commit. It's like if you just need one commit from another branch, that's when you can use cherry pick. The one thing to bear in mind is that if you use cherry pick instead of merge, the problem is that the two hashes will be different because they're in different in the history. So that's why people, I know developers have been confused by the fact that it's the same commit, but it's got two different hashes. I don't understand. And that's when you use cherry pick, that's what happens. So revert commit is a sort of a tool that you can use that if you don't like a commit, you can just do a revert. I'm not going to use my tooling because I need to, be more hardcore and show you rather from command line. So we're going to revert this commit here. We're going to go get revert, and it's, what is its hash? E57B, E57B. And this is, it wants to know what the commit comment is. We're going to just leave it as default. So now in the repo, we're going to see there's our revert. Okay, so it's basically played out a reverse of what happened in this commit. So now this commit added the fourth file.txt. This revert is now taken it away. So if you have some rogue code that you need to remove, this is often quite a useful way. It goes without saying, however, that if there's a merge conflict, so there's been another change to this commit subsequently, you're going to get a merge conflict and you're going to have to deal with it. Okay, so then we've got rewrite history. We've kind of covered that already. And then there's something very interesting that Git supports, which is called an index or staging area. And the tooling doesn't all support this to the same extent. I'm not 100% sure why, but basically what you can do with Git is, what you don't realize is that Git has got the staging area that you can put files into. And I'm going to use Eclipse to demonstrate this. So here's my file, right? And I'm going to go, oh boy, all right. I see we have time up, which I sort of was worried about. I haven't got much left to go, so let me just finish the slide, and we can have some questions potentially. We've got index.staging. Here we have, let's put this in. This is one commit. This is another. This is the one change. This is another. Okay. So with our staging area, what we can actually do is we can go, let's actually, I only want the one change, but now you see it's not going to let me only do one change. We're going to have to work a bit harder if we wanted to do multiple changes. Let's do this. This is before. So now we're going to go, I only want that change, or rather I only want that change. We can do that. And now we can only commit, this is only one of the changes. Right. And then just briefly, what is a detached head? So remember we talked about how there's these pointers to the various places. Detached head basically is when we haven't got one of those pointers checked out, but we've got an absolute state of the repo checked out. So we're going to check out this. We're going to go get checkout that one. Yes, we're going to do that. Come on, how do I do that? Let me just do a reset quickly. So we can stop that happening. Okay, and we're going to go like that. And now we're in detached head state. What that means is that there isn't a pointer. None of the pointers are in operation. We're in sort of a snapshot place, so we can't actually commit and expect it to be tracked. That's why it gives you this long story sort of warning. All right. There you are. Thank you very much. I hope you were able to follow. If you want any more ask any more questions, or take it up tomorrow or whatever, you're welcome to. I certainly enjoyed finding out more about it. So thank you very much.